Hello folks, I'm Dave. I've been doing security, specialist SAing in security and compliance at AWS for about 3¼ years now, and I've been doing security in general for probably a quarter of a century longer than that. So I've been around the block a few times and done a whole bunch of projects in a whole bunch of industries. This talk is intended to follow along from Paul's previous session, which I hope a great many of you were here for and enjoyed. A little observation to begin with, actually. I mean, there's an old saying in security that security is 70% people, policy and procedure and 30% what you do to the computers. I hope I can help convince you during this session that if you apply appropriate security controls that AWS offers you and do a bunch of automation around them, then that's probably more a 60-40 split now. But certainly when it comes to actually doing DevOps and then putting security into the middle of it, there is, from a people perspective, there is probably no greater motivation for a developer to write tight and secure code than knowing he's going to have to run and maintain it in production. But anyway, on with the session. I've got a fair bit to get through today, so I am going to have to go fairly quickly. Apologies to the lady translating into Hebrew in the corner. I hope she's not going to have too hard a time keeping up. So I'm going to start actually with a nice piece of good news, which is the AWS Serverless Application Repository. This is something that we launched without a great deal of fanfare, to be honest, about 2.5 weeks ago. Who here is, hands up please, who here is actually looking at it, using it? Who's had a play so far? Not a one. Okay, well, as I said, it launched without no fanfare. The no fanfare was clearly very loud, well, the silence was clearly very loudly heard. But what you wind up actually having is a new online, essentially a portal, which gives you access to a whole bunch of Lambda functions and other capabilities. I expect at some point there'll be things like API gateway, Swagger definitions, and so forth coming along as well, although everything gets packaged up as SAM, which I'll get onto in a moment. So we have our serverless application repository. There it is. Go have a look at it. And if you actually log into your AWS environment and open it up, you'll find just tons and tons and tons, about 180 of them so far, of Lambda functions wrapped up in SAM with API gateway definitions, potentially DynamoDB definitions as well. And you also, from the point of view of SAM, can go here in order to actually get the details on what it is, how to use it, and how to package your environments. All these functions here are free to use. It's a condition of functions being published in the serverless application repository that the source code for them is made available. So even if a function in here doesn't exactly fit your workload requirement, you should be able to download the version from here, open it up, look at the documentation, see where the source code is, go get that and modify it to your requirements. Everything in here also is MIT-like, well, all the AWS functions that are in here that we actually wrote to seed the repository to begin with are MIT licensed, so again, you can look at them and make use of them for your own purposes. So SAM, if you haven't come across it, everyone here familiar with our favorite squirrel? Not that many again. It's an abstraction on CloudFormation that's intended primarily for making easily reproducible and easily software deployable and automatable serverless frameworks easy to deploy. So it abstracts on CloudFormation, as mentioned, specifically to deal with Lambda functions, API gateways, DynamoDB tables. And SAM also incorporates its own mechanism for actually doing event triggering. It supports the usual suspects that you would expect, and a bunch more. So you can actually trigger in SAM Lambda functions based on IoT, and it even integrates with the Alexa Skills framework. So again, you can go packaging Alexa integration capability up as SAM and trigger on a skill invocation. For offline testing and simulation, Paul is a very modest chap, our previous presenter. He's actually the co-author of SAM Local, which enables you to actually stand up your SAM prototype environment in a simulated Lambda and API gateway world that's all based on Docker containers. And I know because he does it himself, it's small and light enough that it can be run on a fairly serious laptop. By the way, when it comes to slides and so forth, these slides will be published after the summit. So unless you have immediate need of going and looking at what's in any of these links, don't worry about taking photos. I don't mind if you do, but the slides will be available so you can save yourself some hassle if you want to. Moving on to development and continuous integration and continuous deployment environments, this really is what DevOps is all about, and also why you need to go putting security right in there from the beginning. Because, as we all know, DevOps is intended to move fast, from actually doing multiple deployments a day, well, multiple deployments a minute in the case of some organizations, through to monitoring performance, monitoring behavior, feeding back, and then actually reintegrating. So you wind up actually having a very fast feedback loop. There's two things about this from a security perspective. First, if you start doing things like putting an extra security stage on the end of your loop, your DevOps guys won't like it. I mean, it'll slow your loop down, or at least it'll be perceived as slowing the loop down because you've got this extra stage, and they will probably try doing timing on it. And second, in security these days, you can't be the abominable no man. You can't be a blocker in the way of stuff getting done, otherwise people will go around you. And to be honest, if you get in their way, it's not good for your organization as a whole. So what you actually need to do is make the desirable way of doing something also be the secure way of doing something by default. If your developers want to use tools that you don't make available, see what those tools do, see if their security is appropriate. If it is, use it, let them use it. If there's something that you think is more secure, then bring it in-house and give it them so that they can. The best way to stop someone using a tool that you don't want them to use is to offer them something better. And I'm speaking from experience on that. The other thing, of course, is again, because the DevOps cycle is intended to be fast, if you go taking your production deployment environment and you're running in a DevOps and securing it using all our appropriate recommendations for whatever industry and compliance requirements you need to operate within, and you then go opening that up for the output of your development environment, then unless your development environment has appropriate security controls in it, you're going to find yourself in an insecure state very, very fast. So again, this is why actually security of your development life cycle is really, really important, but we have to hit a pragmatic balance point to do appropriate security while not getting in people's way. So I'm going to run through a few things that we can actually do to put security controls in place in a DevOps environment. This is actually a little bit deeper than I've gone before when talking about DevSecOps. I mean, here I am in Tel Aviv, and it's good to be back, and I see Israel as being essentially security technology startup central planet Earth. So I'm hoping that a whole bunch of this is stuff that you're either doing already, or if you're not, that it's stuff that you'll be adopting shortly. So an obvious integration point is Git hooks. You then have APIs that you can go calling from your continuous integration environment, whether just using APIs or tools like Jenkins. And then finally, if you're doing continuous deployment, you absolutely need to be doing continuous penetration testing, and hey, I've got an architecture for that. So if you look at a typical CICD pipeline, those of you who are doing CICD, please put your hands up if this bears a an at least moderate relationship to what you're currently using. We got a few hands. This is good. So if you take a look at this through security-tinted glasses, what you wind up seeing is this. These are all the places in your pipeline where you have the opportunity to insert useful and often reasonably lightweight security controls. So I'm going to take these one at a time. So if we look at code validation as a piece of work that you would trigger when your developer goes submitting a piece of code into your version control system. For version control these days, you can pretty much read Git, at which point there's a few ways of doing things. So for native private Git, you have Git hooks. And we actually have a tool on our AWS Labs account on GitHub called Git Secrets, which it's been around for a little while. A few people know about it. But the fact that people still keep hardwiring AWS keys into their code and then going and accidentally posting it to GitHub without redacting the keys means that not everyone's using it. So if you tie Git Secrets in as a Git hook to your Git environment, then when you go actually pushing your code upwards, it'll go regex scanning your source to see if there's anything in there that looks like an AWS access key or secret access key pair, and it'll then go stop that push if it sees it happening. So the primary vector that people mishandle their keys via is something that we can actually deal with. Obviously, of course, please don't go hardwiring keys into your code anyway. Please run your code in a role, whether it be in its EC2 instance or its Lambda function or its ECS or now, of course, EKS or Fargate container. And that way you just wind up not needing to put any keys in there at all. If you're GitHub users, and hey, one way or another, I expect a lot of us are, you can actually do something very similar, again using AWS technologies, with GitHub natively. GitHub offers something very analogous to regular Git hooks with GitHub webhooks, and I would very much recommend having a look at this very detailed blog posting here, which actually enables you to use a Lambda function as your remediation to seeing an alarm via a Git hook. So you can actually turn Lambda functions into GitHub Bots, and this again is something that you may want to do just in a manner of augmenting your source control and source management, even without considering using it in a manner analogous to Git Secrets. So let's now move on into auditing and validation. And for auditing and validation here, people typically wind up looking at things like static code analysis. So there's a few ways in which you can actually go calling out to external tools to do auditing and validation of your code. A thing that we launched at reInvent and which is just becoming available via some marketplace capabilities is Private Link. This is a really neat thing because, of course, some people still have their concerns about actually making an API call out to the Amazon boundary network, which from a threat risk perspective you need to treat as being analogous to the internet because all AWS customers have access to it. And as we all know, having a credit card doesn't necessarily make you a good person. So if you think about what we did a couple of years ago with S3 private VPC endpoints, which then also got extended to DynamoDB, Private Link is the generalization of this capability to a whole bunch of other services. What you're able to actually do is if you stand up an NLB, our new load balancer that we announced at reInvent, you can extend from that NLB an ENI, not only cross VPC, but also cross account, to give you effectively a private endpoint for whatever service your NLB is offering. So you can back your NLB with a RESTful service, or and then actually these can be offered through Marketplace as well. So alternative ways to do this is using traditional RESTful APIs through API endpoints that are on the public internet. And of course, in that case, you also need to ensure that the functions you're calling those APIs from, again, using Lambda to stick things together, have a routable signal path out to that API presentation point, whether directly or if you're running in a VPC via something like a Squid proxy, so you can go whitelisting the URLs. I picked some local vendors of useful static analysis tools as an example to show different ways in which they're called. So if we start in the middle here with Veracode, their interface actually isn't JSON, but rather XML. So what you can actually do, rather than look at it like a SIG-v4 call, is just curl it. I'll also point out at this point, we have a couple of secrets here that we would want to go substituting in when we go making our call. And I'll be talking in a little bit about how you can actually do this automatically and programmatically using Systems Manager Parameter Store. But I don't like being a 3-pass compiler, so I try and minimize my forward references. WhiteSource have direct GitHub integration, and the guys at Checkmarks, again, you have an API exposed, you go calling it, it's a regular RESTful API, they've got their documentation as to how you do it there. If you're using Jenkins, by the way, who is? Lots of Jenkins users. Happy Jenkins users? Some. So these guys have intrinsic Jenkins plugins. Jenkins plugins are a very popular way to integrate extra tooling like external static analysis into your CI pipeline. We even have a plugin for Jenkins for our code build capability to actually do your compiling for you. And while Jenkins plugins proliferate, you probably want to have a system for doing plugin management. And I came across this one from Pragma the other day, which I actually rather like. Incidentally, when it comes to the references and reading at the end, one thing I do very much recommend reading is where I got this from. Any subscribers in here to DevOps Weekly? Just the one, okay. Obviously, not all innovation happens at AWS. DevOps Weekly, which link at the end, is a free email newsletter. It comes out on a Sunday afternoon, and I've been a happy subscriber for a couple of years. There's nearly always, every week, at least one good link to a piece of security technology in there. So I happen to be a fan. I like reading it on a Sunday evening. So if we get back now to our diagram, let's look at continuous scanning. What do we actually mean here? Well, we can mean a couple of things, actually. First thing, obviously, is dependency checking. Your own code may be tight, but you may actually be linking against libraries that aren't. These could be versions of libraries that actually have CVEs against them, or they could merely be old versions that have been deprecated in the light of new versions that have come out. How are you actually going to check that your dependencies of your code are themselves sound? So the Lambda runtime environment is, for all practical purposes, a regular Amazon Linux userland. You can expect what's in there to be reasonably current, but you may want to be absolutely doubly sure and actually package up package up libraries into your own environment that you ship as a zip file as part of your own Lambda environment. And again, this is where you can wind up doing your own checking. Both look at version info and CVEs at link and import time. The guys at WhiteSource actually have a fun browser plugin as well. I also know that in the CICD front, my friends at Dome9 are doing some things in this space, although I haven't caught up with them yet to find out what. I'll be doing so tomorrow. Shows I don't get to Israel often enough. They've got this whole new product and I haven't seen it yet. Black Duck, who got bought by Synopsys, obviously are also particularly well known for doing this both in terms of dependency management and also license management, which I know WhiteSource also do. So if, for example, you're linking against a piece of open source code that happens to be GPLv3 and you're only happy with GPLv2, these tools will actually flag that up as well. So we're starting to get actually very meta about our dependencies and compliance. The other things that you may want to do is actually do scanning on things like your SAM templates and your CloudFormation templates, which are themselves ultimately just text files. So you can grep through them, look for regexps, look for patterns of IP addresses, for example, which may betray someone trying to deploy a development and test workload into a production environment, so you can stop it at that point. And of course, you can just use the text decomposition and analysis tools of your choice in whatever language you choose. Checksumming is something that some people want to do, very much more of a holdover from doing CICD in traditional on-premise environments. So I actually have a little bit of a question mark over checksumming when you start looking at AWS, especially if you're coming out of a package build environment to produce an AMI. So for package building here, HashiCorp Packer, anybody? A few. Packer is very featureful. It works very well. It can be fun to configure. If you want to start with an existing AMI and just change it a little bit, say update a package here and there, it can be a bit fun to push through Packer again. So you may want to look at Systems Manager Automate as potentially a means of AMI maintenance and doing maintenance more easily compared to actually building an AMI completely from scratch. But anyway, back to checksumming. In an AWS environment, do you really need to? It's a fact that's moderately well known, I think it's fair to say, that AMIs ultimately are stored in S3. And S3, while everyone makes it pretend to be a file system and look like a file system, it isn't a file system, it's a key value object store. And what this means is that with your AMI being an object, okay, a very large and binary one, it is in itself an atomic entity, which makes the AMI itself immutable unless you rip and replace the whole thing. There is no way to actually do any bitwise or file-wise editing on an AMI once it's been created. So in terms of checksumming, this is where I have a question as to whether it's something that's really necessary. But some people may have controls that require it. Finally, before you go pushing things out to your various deployment environments, all these entities are going to be generating logs anyway. If they're AWS services that you're using, like Systems Manager, they're going to be generating CloudTrail records, as you call them. You can, from your Jenkins environments, for example, use the CloudWatch Events agent, CloudWatch Logs agent, or an agent of your choosing for your security incident and event management and monitoring system to scrape the log files from those EC2 instances that your services are running on and push them into either into CloudWatch or into your incident and event management and monitoring system as mentioned. Logs, of course, make great evidence in the event of something questionable happening and you needing to do any forensic tracking back. And for your promotion process into different environments, this normally in the form of things like CloudFormation or code deploy or ECS containers, they themselves will also generate CloudTrail records for you to show what went where. Penetration testing. Definitely read this if you haven't already. You may be pleasantly surprised. We've been working quietly for a long time in the background to try and increase the number of services that are within scope for being pen testable by by yourselves or other external testing companies who you choose to appoint. If you're getting traditional pen testing done on EC2, definitely deploy Inspector on your instances when they get tested so that you can actually get information from inside your instance. Ideally run this in continuous scanning mode as to whether any testing, any badness that your testers throw at it, your application, causes any misbehavior even in transient form. Inspector, if you run it in continuous assessment mode, it'll actually pick up on any changes in your application's posture which might be applicable to CVEs, even if they only exist for a millisecond, it'll spot them. Also, in terms of tools that may be pre-packaged, there's a whole bunch out there, including, again, a couple of local guys. OWASP Zap, of course, is very well known for doing the OWASP Web Top 10 and others. Or indeed, if you're a pen test service penetration provider, pen test service provider yourselves, and I know there's a few out in this part of the world, we've got an architecture for actually doing this. So if I'm going to walk through the customer side of this specifically. I'm not going to deal hugely with the pen test provider piece. If you want to talk to me about it, please catch me afterwards. I am around all day. So let's look at a little bit of workflow here. If we've got our developer putting code into code commit, that can get picked up by Code Pipeline, which as part of what it does will potentially wind up doing a bit of integration, maybe using something like code build. You'll definitely wind up running another Code Pipeline step, hopefully involving testing your code on an EC2 instance that happens to be instrumented with Inspector. Let's say we're then deploying that code using code deploy. We go push that up into a staging environment here. It's based on EC2, so we've got some instances. We may be pushing a package up here. But what we can then do from our code pipeline as our last step is we can run a Lambda function. So this Lambda function, let's say we've got a pen test provider over here that we like using who provide automated pen testing as a service. Chances are they provide a menu of tests that they will run for you, probably just on some static website. You can put together, from what you know of your deployment here, from Code Pipeline, effectively a job spec involving some unique identifier, normally the software version of the package that you want to test, a list of the tests from their menu that you want them to run, definitely also the means to write to an S3 bucket. You'd normally do this via something like a one-shot signed S3 URL, and your own identifier in terms so that they can actually bill you, plus, of course, the information about the target to attack. Send that over to them. They will wind up running their attacks. They will drop the output of those attacks in the form of a report, essentially probably just the console logs from their attack tooling in your S3 bucket. You can then from there trigger a Lambda function from that write action, grep through the report, and based on whether there are any fails or not, you can choose what to do. Obviously, if there's fails, you'd probably want to extract the version number, take the copies of the fails, post that to an SNS topic that can maybe go and integrate in Jira or some other bug management system, or just be subscribed to by the engineering team who are looking after this piece of software so that they know the test has failed and have a view on what they may need to do. If there are no fails, then at this point, if you're the kind of organization that's been doing actually happy doing continuous deployment, you could then go kick off another flow, maybe another code deploy, to actually take that version of the code and push it to production. So this is how you can actually do decent, rigorous testing in an automated fashion to make your code ready for actually going to production deployment. But to get a bit meta, Don't forget to consider the security of your security tooling. And this is where Lambda can get fun. The thing about Lambda functions is they're really easy to deploy, and there really is no shortcut for good design, even though you may just want to get your sleeves up and get in there. But in terms of the third-party tools that you want to deploy, obviously you want to make sure everything's done over HTTPS if you're calling internet-side endpoints, and you want to do diligence on the providers of those services. So go and see what they've got in terms of audit reports, go see what is said about them in the industry in general. But for your own Lambda security, there are a few important rules of thumb. So from the point of view of least privilege and privilege scope constraint, we say one function, one purpose, one IAM role. And as far as how you can generate those IAM roles, rather than go necessarily poking around with IAM yourself, our friends at PureSec have actually released a tool on GitHub that will do static analysis of your Lambda function source, and from that emit a least privilege IAM role that you could go running that Lambda function in. It's a fairly new tool, but if it's something that you think might make your lives easier, by all means download and experiment. There's some arguments happen in both directions about whether or not to run your Lambda functions in a VPC. People who particularly focus on performance aren't keen on it because actually standing a Lambda function up inside a VPC adds overhead at cold start time, because you've got to go creating a new ENI, you've got to hang security groups on it. It adds a little more to the start time. I say consider your threat model. My view is that everything starts with a threat model, quite a few things end with it. And if you consider exfiltration to be an important threat against what your Lambda function may be doing, then you might actually want to go running in a VPC, because you have the ability to hang security groups on your Lambda function because it's all operating through an ENI. You also, if you don't want to go giving it direct internet connection, have the ability to go talking through proxies such as Squid to do whitelisting of where your Lambda function can actually go connecting to. So again, there is a balance to be found depending on what your priorities are. Everything comes out of your threat model. I read last year sometime actually, Guy Pajani from Sneak, he produced, he did a really good session at Serverless Conf. This is the link to his slides. I highly recommend reading them. And obviously you can think about them some more than you can in my brief session here. Also, again, friends at PureSec have got some very interesting new tooling for Lambda function monitoring and management, and also privilege control within the Lambda environment. And it then becomes an interesting question as to whether, from, again, your threat risk perspective, what goes on here will suitably compensate for not putting your Lambda function in a VPC, as to whether you may want to be able to substitute one for the other. Secrets management. I mentioned earlier, as we showed on the as we showed on the external API calls, often you need to go making API calls that have credentials in them. So how are you going to do that? You really don't want to go hardwiring them into the source code of your Lambda functions. So use Systems Manager Parameter Store. It's what we built it for. What you need to do is you need to give your Lambda function an IAM role with these parameters in it, and ensure the KMS key that you're going to be encrypting your secrets with has this policy, so your Lambda function can actually go decrypting it. How you'd go about using this, here's a CLI example that I actually use in my own environment for putting RSA private keys into newly spun up EC2 instances that are running Apache. So if we look at the top here, we've got the truncated value, which is my private key. We note it as being a type secure string, which means we want to encrypt it with KMS at rest. Here's the KMS key ID that we encrypt it with, and we're just calling it my private key. Now, in the cloud init script that I then go running on my instances, I have a standard Unix command, cat, something a little bit interesting, essentially my key, to the usual place where my Apache expects to find its private key, doing the usual chown and chmod, and then let's run it. When you wrap this up in send command, and in the context of Lambda functions, SSM is actually part of the Lambda runtime environment anyway, so you don't need to go installing a package here. I can run this command targeted against anything that is tagged as being a web server, which in the case of my web server, of course, includes itself. And then when my command goes out to Systems Manager, Parameter Store will take my private key and substitute it in here. So what actually runs on my Linux box at the end of the day is this thing in curly brackets replaced with the value of my private key. So I'm just literally just catting my key to where it needs to be and letting things go. So you can use this for things like credentials for external scanning. Most people use it more often than that for things like database connection credentials. You get the idea. You don't need to go hardwiring any secrets into your Lambda code. And also, if you need to rotate your secrets based on policy, you can rotate them up here by doing a new put parameter without having to change your code actually in your function. So logging and alerting environments. I'm going to go through CloudWatch Events a little bit. I'm going to need to speed up because I'm running short on time here. CloudWatch Events, everyone uses it because it is quite simply the lowest latency AWS logging and alerting mechanism. It's also pretty simple to parse, and it has a huge range of event sources available. So to actually make use of it and create your first rule, you can just, using the console, select from the drop-down that you want to use an API call as an event source. Let's say that we're picking up on CloudTrail here, and we want to pick up on any actions to either delete the trail or stop logging, because these are things that people really shouldn't be doing with CloudFront. With CloudTrail. If they do, then what we actually want to do is run this Lambda function here and essentially let it all go. In terms of what a CloudWatch event record actually looks like, once we've got one, we can do this with it, and indeed this is what we'd normally do inside our Lambda function, maybe minus the print bit, and here's our record. Hope you can all see it. The interesting things that happen in it actually happen in the second half. So we can see here that the entity that has tried to be affected is this CloudTrail trail. Bob, our intern here, has gone and made a call. It was invoked by signinamazon.aws.com, so this was run from the console. These were the keys that Bob authenticated with, and he tried to make CloudTrail stop logging. We don't want that. So we can actually respond to that once we've parsed our event with just actually, let's turn this thing back on again. We probably also want to know the fact that this has happened, so we can actually push details of that event to SNS, which can then potentially get picked up by SES and send us a nice email so that we can see that this has happened. And of course, the running of our Lambda function actually goes and logs itself as well, as indeed does posting to stream. Log redaction is something that is pretty new on the menu. My mate Bertram Dorn, who works in the same job role as me and is based in Germany, Bertram is trained in his background as a data protection officer, and with German law being what it is, the fact that logs contain things like email addresses and tuples of source IP addresses and timestamps were things that he had to think about and decided that if you wanted to go shipping logs cross-region, you may need to make a few changes to it. So let's look at what we can do here. If we've got CloudTrail and config going to our bucket, going to our S3 bucket, and potentially events being generated from EC2 instances into CloudWatch, we can actually take a Lambda function, read from CloudWatch and drop those into our S3 bucket before we can also at this point also still use CloudWatch and CloudWatch Events as a trigger for our response Lambda functions, which I probably won't have time to cover here, unfortunately. And then we would use a Lambda function to take all that consolidated log data and ship it to some remote account, which just has an S3 bucket holding all our log data beyond the reach of these guys here. We may actually want to do some redaction in another Lambda function here. So we have unredacted data here, redacted data here, redaction, and then just shipping. How we go about doing that, whoops, what happened? Here we go. So we take our redaction function, trigger it on S3 put object, unzip our log records if we need to, walk through the JSON, identify any PII based on what the keys are, replace it with asterisks, do the same thing for any other data we consider sensitive, zip it back up again, create an alert if we found anything sensitive, and pass it on. We are working, Bertram's actually got a minimal function for doing this with CloudTrail. We're working on open sourcing it. Hopefully, the new function repository is going to make that easier. The function itself doesn't need much in the way of roles. Now, if you go deploying this kind of logging environment in your developer accounts, because each developer is very likely to want and have a genuine need of their own AWS account, how do you stop them breaking the logging environment that you've so carefully set up with a CloudFormation template when you automatically provision their account? Organizations SCPs. At this point, I really am going to run out of time for this bit, so I'll point you to my session at reInvent where I went through this in a bunch more detail and gave a bunch of examples. GuardDuty. Threat intelligence as a service. It's been talked about a little bit earlier today. What it can actually detect, it is a whole bunch of stuff. This slide is now actually slightly out of date. GuardDuty added 12 new detections just 2 Sundays ago and is now up to 46. The guys on the GuardDuty team are iterating very fast regarding what they're able to add. These are the categories of things that GuardDuty can detect, and there is a full list of detections and what they cover here. As you might expect, one of the things that's picked up is cryptocurrency, because when people find mishandled keys, as mentioned earlier, one of the first things that they typically do is, because of the nature of the economics, is start mining Bitcoin. This can pick this up and stop it, but a very common thing that I also get asked about that GuardDuty can look at and find is DNS-based exfiltration. So GuardDuty is really easy to turn on, very easy to use. I recommend you do so. In fact, what GuardDuty actually does is it outputs to CloudWatch Events, again, our favorite log source. GuardDuty findings actually come with characterization including GuardDuty's own risk measure. So when you feed that into a Lambda function, we actually have an integration example at AWS samples rather than AWS labs, which can take your GuardDuty findings and send them to the Slack channel of your choice. Customers that we've spoken to, they send the low priority stuff to a Slack channel, often just a Slack noise channel that the admins keep an eye on. More severe ones can go to a specific higher severity Slack channel for admins and maybe an escalation path. Really severe ones you can just send through to PagerDuty. In production environments, I'm probably going to have to cut myself short at this point because I'm pretty much out of time, But again, this is something that I ran through in that reInvent session that's linked to earlier, so you can go look at it there. The idea here is to deal with the issue where our hapless intern, Bob, who's probably new in his role, wants to launch an EC2 instance, and we need to check if he's launching an appropriate AMI in an appropriate context from the point of view of security groups, subnets, VPCs, etc. So that launch event gets picked up by CloudWatch Events. That can trigger a Lambda function, which can check if our AMI is approved, etc. That can be done by against policy, which would go putting in somewhere like DynamoDB rather than hardwiring into your Lambda function. If Bob's instance is deemed inappropriate, that can go kick off another event, which can go terminate his instance, probably even before it's up, bearing in mind that a Linux instance takes about a minute to launch. WAF and not in the context of serverless and Lambda. We do have our new WAF managed rules. If your Lambdas are internet-facing and if they're processing regular URLs, then WAF is a good thing. But ultimately, again, it's down to your own risk appetite based on what the context of your environment is. So again, it's a thing to be aware of, thing to think about, and to suit and to fit as you need. We have our own new serverless application lens white paper, which we published right at the end of last year. I also, certainly for the programmers in the room, I recommend PureSec's white paper on serverless most common weaknesses. There's actually worked examples in there on both how it gets done wrong and how to do it right. And as mentioned already, I'm a big fan of DevOps Weekly. So Lambda really caused a bit of a stir when it first came out, and there was a zeitgeist among the even among the AWS SAs that this meme was the right thing to do. Ultimately, it comes down to context. Lambda is actually really, really good for a lot of stuff. The glue service is called glue, certainly, but in many people's environments, it's Lambda that holds the universe together. So I hope this has been interesting. I've run slightly over time, but thank you.